Alrighty, so we're going over the quiz here from yesterday. Question number 1, there was 2 possibilities that you could do. Miles to go is traveling along Lake Street at 25 feet per second. Miles accelerates at minus 2 feet per second squared. Determine the distance traveled by miles in 10 seconds. You'll remember that when you're solving for distance, right, it's V bar is equal to D over T. So you need to find the average velocity first. The average velocity. Now what do we have here? We have an initial velocity of 25, right? And he's accelerating at minus 2. So is my VI equal to my V bar? No, because this guy is slowing down. So you need to figure out what the average velocity is. And the only way to get average velocity, right? This should be D over T, shouldn't it? The only way to get average velocity is either D over T or VI plus VF over 2. And the only way we need to get the distance, so I need the average velocity before I can get the distance. So in other words, I need to find the VF first. I need to find his final velocity. So I'm going to use my A value, and I'm going to use my T value to get my delta V, right? So the first step is going to be A equals delta V over delta T. Minus T is equal to delta V over 10. My change in velocity is minus 20. So I've got my delta V. Now I need to find my VF. So I'm going to write delta V is VF minus VI minus 20. Write it right underneath. Minus 20 is equal to final velocity minus 25. My minus 25 goes over to the other side, becomes positive, and I get 25 minus 20. My final velocity is 5. And doesn't that make sense? Right? If I'm changing my minus 2 for 10 seconds, right? Minus 2, minus 2, minus 2, minus 2, minus 2, 10 times, I'm going to end up at 5. And now I can go V bar is VI plus VF all over 2. And now I can go 25 plus 5 divided by 2, giving me 30 over 2, or 15. My average velocity is 15. You'll notice that my initial velocity was 25, my final is 5, my average is 15, and my delta V is 20. All 4 V's are 4 different numbers. Okay? Only in some cases are some of them equal to each other. Okay, so make sure you know that. Now we go V bar equals D over T. 15 is equal to my distance traveled in 10. 150, I guess it's feet, isn't it? Let's look at the second one. 2 ants racing across the entire length of the top of a Wheaties box at a constant speed. The box is 34 centimeters long. One ant travels at 4.6 centimeters, the other one at 3.5. The fastest ant will cross the finish line first, of course. How much time will pass between the time that the first one and the second one cross? So in other words, what's the difference in times? So you're going to solve for time. Right? Constant speed, constant velocity. 4.6 is the one. Now, do I need to change that to meters, do you think? That one's in centimeters per second. The box is in centimeters, so as long as I keep it the same, right? My time here is 34 divided by 4.6. Somebody help me out here. 34 divided by 4.6. I don't have a calculator. How much? 7.39. Okay. We're going to do the same thing for ant number 2. Ant number 2 is running at 3.5. Same distance, same process. 34 divided by 4.6. No, it's not 30. 3.5. 9 point what? 9.71. So what's the difference in times? That one's pretty easy. Delta T is simply going to be 9.71 minus 7.39. What's that one work up to, Regan?
I didn't do that.
Oh, you didn't do that one?
I just found what they were.
You couldn't do it for me right now?
I don't know. I'm not good at mental math.
2.32.
Oh, that's close.
I'll do it right now.
That one's definitely, I already got it done. That one's pretty easy, right? It's easier than the other one.
That's why I did it.
Good move.
I didn't do it.
Number 2, melt in your mouth. Is hurried to his workplace at Chocolates Inc. Pause for laughter. When he observes a multi-car pileup on the interstate, Milton Your Mouth is moving at 33 meters per second. His accurate legend can accelerate at minus 8.5 meters per second squared. Determine his braking distance. When we're looking for distance, we have to use V bar. We have to use average velocity. Average velocity. What is his initial velocity? What is his final velocity? Why is it 0? He's stopping. I don't have average velocity. What is his delta V? If he goes from 33 to 0, his delta V is minus 33, but I need his average.
Wouldn't it be 33?
No. He goes from 33 to 0. If you got 33 on one test and a 0 on the other test, what's your average?
Oh.
What does average mean? This is the number one key point of this whole unit, is do you know what average velocity means? It's absolutely number one. You've got to know it.
No.
Yeah, that's what average means. That's what average means. So it's going to be 33 plus 0 divided by 2, which of course is
16.5.
16.5. And now I'm doing braking distance. Do I know his time? I don't know the time yet, do I? I have to determine the time. A equals delta V over delta T. Minus 8.5 is minus 33 over time. Somebody help me out here.
3.88.
What is it?
3.88.
3.8. Okay. And now that we've got our time and we've got our average velocity, we should be able to go V bar is D over T. 16.5 is my D over 3.88. And I get a displacement of, somebody help me out here, 3 times 16. 48. It's about 52 or so, something like that.
Oh, you confused me with that last one.
Why did you do that?
Negative 33 divided by 1.5.
That's the time.
That's time.
It's asking for a braking distance bit.
No, I know, but is that the answer for time?
That's the answer for time. Can somebody help me out with 16.5 times 3.88?
64.02.
64 meters. Okay? Just takes practice. You just got to do them. It might even help to redo the same question over and over and over again. Let's look at number 3. You got a graph. It asks you for the the distance traveled. This is a VT graph. How do we find displacement? From a VT graph, we find the area. So it's 1/2 the base times the height. The base is 32. The height is 8. Half of 32 is 16. 16 times 8?
128 meters.
100 what?
128
That sounds right.
meters squared, right?
No, meters. Even though it's an area, it's because this is meters per second and this is seconds, and so it's meters per second times seconds. The seconds cancel and your unit is meters. So even though it's area, it's not square meters, it's meters.
So essentially you just found
I found the displacement.
but it asked the distance. So
Okay,
that's the
yeah, same thing, yeah. Distance traveled. Sometimes the displacement and the distance are the same. All right, and the last one, wrecks things. Drops his grandmother's vase in the top of a high-rise.
These are the worst possible parts. It's just,
I tried that.
it's just outstanding.
I was walking my dog once, and this little kid stopped me, and he says to me, "What's your dog's name?" And I said, "Buster." And he says, "Do you call him that because he busts things?" And I laughed, and I said, "No." And he goes, "We have a dog. His name is Rex. We call him that because he wrecks things." True story.
But you left
That's a
recording
good, that's a
on
good
it.
name though.
Yeah, I knew, 'cause you can listen to it again.
I'm so excited.
True story. Okay, so I've got a time, 1, 0, 1, 2, 3, and 4. Yeah, the acceleration is 10, so the initial velocity is 0, and it simply goes up by
Tens.
tens. That's all. That's all it is. All right, I'm done. You guys have the rest of the period. If you didn't hand this thing in, I need it today, or I'm giving you the alternative one, and I will let you know who I have. Okay? Because I want to give these back to people today so they know what they need to work on before the test. So I need these today.
Oh, Lord.
Do what you need. Got my